Well, I was rudely interrupted by the video running out of time. So let's keep going. In the last video, we set it up using integration by parts twice, and we got our integral to equal this little piece of a mess here. But notice that this integral cosine x e to the 2x dx is the integral of cosine x e to the 2x dx. So if we call this integral I for integral, then I is equal to this I. So I can rewrite my problem as I equals the sine of x e to the 2x minus twice negative e to the 2x cosine of x plus twice I. Right? This is I, and this is I. Now, let's go ahead and do some algebra and see if we can solve this for I. I get I equals sine of x e to the 2x minus or plus 2e to the 2x cosine x by multiplying through minus 4I. So here I have I, and here I have minus 4I. Well, I could just add 4I to both sides. And so I get 5I equals the sine of x e to the 2x plus twice e to the 2x cosine of x. That means that my integral I is just this thing divided by 5. And let's add our favorite plus c. And that's it. We were able to find an antiderivative for this by solving algebraically for it. So this is our final solution. This is how we find I. So this really only ever happens when we have trig functions, exponentials happening together. There's a couple other really cool examples of how to do integration by parts to find particular antiderivatives. So let me show you a couple. And then the rest you'll probably do as homework and in the exercises. So post on discussion boards. The first one I want to show you is how to integrate the natural log. All right, I want to find the integral of the natural log of x dx. Now you're going to say, wait a second. There's no multiplication here. Yeah, there isn't. But we could always view this as the function 1 dx. So we could definitely say u is the natural log of x, and dv is just dx. Right? And then when we do this, then du is the derivative of the natural log is 1 over x dx. And the antiderivative of dx is just x. So this looks promising because then what we get is u times v, x natural log of x, minus the integral of v du. And v is x, and du is 1 over x dx. And now we see that we're just integrating 1. So we get x natural log of x minus the integral of 1, which is x, plus c. So this is kind of a cool, clever way to find the antiderivative of natural log. By using integration by parts, we can actually get rid of the natural log by taking its derivative. And it does simplify with the 1 over x and the x. And we're able to integrate. This isn't the only function that we can now find an antiderivative from like this. Let me show you how we do arcsine. Right? So in the first video, we found how to find the derivative of arcsine. To integrate arcsine, we're going to use integration by parts. And we're going to set it up just like we did with a natural log right here, so that we're going to have u is going to be the arcsine of x. We can do this because we now know how to find its derivative. And we're going to have dv be just dx. The derivative of arcsine we saw is the square root of 1 minus x squared. So that works fine. The derivative of, v, the antiderivative of dx is just given dx. And so now we're in a pretty good shape. I just need to decorate here with my dx. And now we're good to go, because we can plug into our integration by parts, and we're going to get u times v, which is going to be x times the arcsine of x minus the integral of v du, which will be x times the square root of 1 minus x squared dx. And now this doesn't look half bad, because this we can integrate via u substitution. If we let over here u be 1 minus x squared, du will be negative 2x dx. And so x dx will be du over negative 2. So x dx will be du over negative 2, and u is going to be 1 minus x squared. And this negative and that negative will also cancel each other out. So we get the integral of arcsine of x dx equals x times the arcsine of x minus the integral of, so x dx I'm going to replace by du over negative 2. And u is 1 minus x squared, so root u. So this is fine. I'm going to pull this negative 2 out front, make it a negative 1/2, cancel with the negatives. So I'm going to get x arcsine of x plus 1/2 of the integral of root u du. And this is a power rule. This is u to the 1/2. So the antiderivative is going to be 2/3 of u to the 3/2. So I'm going to get x times the arcsine of x plus 1/2 of u to the 3/2 over 3/2 plus c. And now we just have to back substitute. So we have x times the arcsine of x. The 1/2 and then the dividing by the 1/2 cancels that. So I'm just going to have u to the 3/2 over 3. So plus 1/3 of the square root. Oh, I shouldn't say the square root. U is just going to be 1 minus x squared to the 3/2 plus c. And that'll do it. So we can use this trick not just for arcsine, but you can do it for finding the antiderivative of arctan or arccosine. All of those you now have access to because you know how to find those derivatives. So go ahead, have fun. Enjoy trying more of these in the examples and in the homework, and I'll see you in the next video.